Hello friends, welcome back to our channel Mechanical Engineering Exams Made Simple. So I have made number of videos boys for your assistant motor vehicle inspector examination for your APPSC and TSPSC. Right? So don't wait for the notifications to come. Those candidates who are serious, please start your preparations now. Already some students have already joined the coaching, online coaching, which is offered by me, and also they have joined long back in the sense that some of them have joined probably 5 to 6 months back, because actually the news of this APPSC and TSPSC notifications are coming, were making rounds for the last 1 or 2 years, more than that. So that's the reason some of them having a long vision, etc. Right? So they have joined early. So definitely always early birds will have always edge. So almost their syllabus is completed. Some of the Andhra Pradesh candidates have completed their syllabus, and for TSPSC Telangana candidates, almost a batch is going to be completed. So I have completed 2 batches for APPSC, AMVI, and 1 batch is going to be completed for your TSPSC Telangana State Public Service Commission for your Assistant Motor Vehicle Inspector examination. So almost their syllabus is almost completed. So definitely those candidates are very serious about this examinations, please think of joining the online coaching which is offered by me. Right, boys? So this video which I am making right now is going to prove very useful for you, because there are questions. I have seen number of papers, your previous papers, okay, maybe all competitive examinations, diploma based or degree based, BTech based, they have asked questions. Definitely you are going to get questions from your shaft. Shaft is a very very important mechanical element which is used in power transmission, as we all know. So in this video, let us see, we are going to see the shaft materials and sizes. So materials for a shaft should possess the following requirements. So what are the requirements? So it should have definitely high strength, and it should have good wear resistance and low notch sensitivity. So what is the notch? Actually, it's a cut made in the material, right? So definitely in the notches, along the notches, there will be a lot of stress concentration. If they are loaded too highly, or if they are subjected to alternative loading, variable loading, definitely they are the stress raisers, and if at all any crack is going to form, it is going to start at that location. So definitely your shaft material should have good, or they should have low notch sensitivity. And then next good property of this shaft material is that its ability to be heat treated. And definitely, so we have to give a lot of heat treatment operations to change its mechanical properties according to our requirements. So definitely it must be able to be heat treated, and also it should have good machinability also, because actually shaft have to be machined to certain lengths and then sizes, diameters. So definitely from this point of view, the shafts should have good machinability. So let us go to the, depending on the requirements, the shafts can be made of plain carbon steel or alloy steel. Plain carbon steel. So there are 3 types of steels, as you know: mild steel, then medium carbon steel, and then your high carbon steel. So all iron and carbon alloys which are having less than 2% of carbon are known as steels, and more than 2% of carbon and remaining iron, they are known as the cast irons. You know that. In the steels we have another classification, like they are subdivided into 3 types. One is the mild steel, then medium carbon steel, then your high carbon steel. So medium mild steel or low carbon steel, it is also named in another way. So it will be having 0.1 to 0.3 percentage of carbon, and medium carbon steels will be having 0.3 to 0.6 percentage of carbon, and high carbon steels will be having 0.6 to 1.3 percentage of carbon. So this is going to vary from book to book, but normally this is the range of mild steel, and then your medium carbon steel, and also your high carbon steel. So let us move further. So they are normally made of plain carbon steel or alloy steels. If they are if for example good mechanical properties are required, so for example resistance against corrosion, etc., if that is the requirement, definitely they are made of alloy steels. So normally, so if any question is given, so you can choose from plain carbon steel or alloy steels. Normally no other material is used. So now all commercial shafts are usually made of carbon steel having 0.25 to 0.4%. So according to the classification just now we have completed, we have seen, so in which category it is going to fall? It is going to fall between 0.1 to 0.3, then 0.3 to 0.6 I said, right? So definitely this is going to be roughly medium carbon steel. So definitely you can choose if low carbon steel or medium carbon steel or high carbon steel. So definitely you can choose the option. All commercial shafts are normally made of medium carbon steel, right, which is having 0.25 to 0.4% of carbon for high strength requirements. So just now I said, so corrosion resistance, etc., and high strength requirements. So if a shaft needs high strength, then definitely it is made of alloy steel such as nickel, then nickel chromium and nickel vanadium steel used. So these are the combinations of alloying elements: nickel, nickel chromium and nickel vanadium. Basically chromium added steels, they will be having a lot of corrosion resistance, good corrosion resistance for such requirements. So this material is used. Shafts are formed either by hot rolling or cold rolling process. So definitely you might go to question, right, which is the manufacturing process which is normally used for the manufacturing of shafts. So definitely it should be either hot rolling or cold rolling process. Next, hot rolled shafts are turned to size and then finished. So they are turned to size and then just now I said, right, so it should have a shaft should have a good machinability. So that means it has to be cut to the size. So that's what he is saying. So he is saying that hot rolled shafts are turned to size and then finished. Cold rolled shafts are stronger than hot rolled shafts. Out of the two methods of manufacturing of steels, hot rolling and cold rolling, so definitely cold rolled shafts are more stronger than your hot rolled shafts. So definitely cold forming or cold working is going to definitely improve the strength. So that is another reason for going for the cold rolled shafts and possess higher residual stresses. Another but only disadvantage with the cold rolled shafts are that they are going to have higher residual stresses, which may ultimately raise stresses. Shafts for special purpose may be forged. So like that a question may be given, right, like what is the general manufacturing process of your shaft? It is definitely cold rolling or hot rolling. But what about a special purpose? So definitely shafts for special purposes are forging. So forging will have its own advantages. So definitely all the forged components will have good density and uniformity of the distribution of the material. That is another reason going for the say forging of the shafts. So due to manufacture and transport difficulties, all commercial shafts are made in standard length of 5 meters, 6 meters and 7 meters. A question may be asked, which is not the standard length of the commercial shafts. So a question may be given like 5, 6, 7, 8 meters may be given. So your answer should be naturally 8. If 4 is given, your answer should be 4. Right? So please remember this table and also all this is the discussion. So the diameters of transmission shafts are given. Table 1. This is another question. Definitely a question may be framed on this. For example, transmission shafts. So what is the next size? He may be asking, right? So this question was also asked in a number of exams, a number of competitive examination, diploma based or maybe your degree based or BTech based. So definitely if a question comes from shafts, definitely a question may be asked from the what is the next size of the shaft. So if you remember this table, you can easily answer the question. So from 25 to 60 mm diameter, the increment is 5. That means if you are having a shaft of 25 mm, what is its next size? It should be 30 mm. Or if you are having a shaft of 55 mm, what should be its next size? It should be 60 mm. Then 60 to 110 mm, it is 10 mm. For example, you are having a shaft of 70 mm. What is the next size? It should be 80 mm. Similarly, 110 to 140 mm, it should be 15. For example, I have got a shaft of 120 mm. So what should be its next size? It should be 110 plus 15, that is 125 mm. So finally, so if I am having a shaft of 150 mm, what should be its next size? If a question is asked like that, so it should be incremented by 20 mm. So that means it should be 170 mm. Okay guys, I hope you have got a good idea about in this video about the shafts and materials and their sizes and their manufacturing process, what are the properties, how shafts are made, manufacturing process, and also what are the standard lengths of shafts, and also what is the transmission shaft's diameter and increments, for example, the next size of the shaft. So once again friends, so if you are watching my YouTube channel regularly, so if you are a subscriber, it's well and good. If you are not a subscriber, please subscribe. It will be having a lot of information for your all competitive examinations, whether Appsc, Tspsc or GATE or any other competitive examination for your mechanical engineering, or it may be useful for even your academic examinations also. So please, if you like my channel, please subscribe, like, comment and share among your groups and contacts. Once again, let us meet in a good video with a good subject and excellent information. Once again, all the best and good luck.